Hello and welcome to the last video on Unit 1.4/5, where we're going to talk about the applications, which we hinted at the very beginning of the first video. So the key thing to understand in order to do these ones is that since the slope can represent a rate, we can solve real life situations that involve related quantities. Be sure to label your variables. I'm not just doing this because I want to be a stickler. It really, really, really helps you get things set up. It's very important. It's not just something because I want to be a stickler, I promise. So all word problems are usually best learned through examples. So with this one, the monthly cost in dollars of a phone plan is a linear function of the total calling time in minutes. And so the plan starts at $34 a month and you are charged 11 cents per minute of usage. How much will your bill be if you were on the phone for 4 hours and 22 minutes this month? So, first and foremost, we can see this as a linear function. Here, let x equal the number of minutes. And it doesn't need to be anything like super detailed. You don't have to say like, let x be the number of minutes, blah, blah, blah. You can just say x equals min and y equals dollars like that. You don't have to, like, as long as you know what you're talking about, but it really helps you get the creative juices flowing. And so this is a linear function where you have time on the x-axis and dollars on the y-axis. And so it says that the plan starts at $34. So that actually tells us what the y-intercept is going to be. So that's our y-intercept. And we know that the plan is going to increase really, really slowly, but it will increase over time. In fact, it'll increase at a rate of 0.11 seconds. So I already did it, but this says that b is equal to 34, and this is m. M is 0.11. So we actually don't even need to find the slope or find 2 points or anything like that. We've got everything we need. Y is equal to 0.11x plus 34. But that's not what the question is asking. It is asking us how much will your bill be if you are on the phone for 4 hours and 22 minutes. Now, you might be tempted to write 4.22, but that's not 4 hours and 22 minutes. We want, like, notice that that time x is measured in minutes. So we need to convert this 4 hours and 22 minutes to purely in minutes. So 4 hours and 22 minutes, you just multiply this by 60, you get 320 plus, or not 320, what am I doing? Thinking 80. 240 plus 22, that's 262 minutes. So we want to know y of 262. Yes, I can write y as a function of x, so I can write y of x. So y of 262 is 0.11 times 262 plus 34, which if you plug that into your calculator, because I don't want you to do that in your head, you will get that it is $62.82. And that is our answer, because that's what the question is asking. It wasn't asking for the equation, it was asking us to find how much your bill will be. We wanted the y value when our x value was 262 minutes, that is. The next one is it's saying, suppose, highlight it, suppose that the height in centimeters of a candle is a linear function for the amount of time in hours it has been burning. After 2 hours of burning, the candle has a height of 23.6 centimeters, and after 5 hours, the candle has a height of 12.9 centimeters. What is the initial height of the candle? So What I'm going to do is I'm going to let x equal time in hours and y equal the height. So we'll see we have a linear function. So I'll go ahead and draw our x-axis. Since we're dealing with time, we don't really need to deal with the left half because we can't have negative time. And since we're not dealing with, we can't have a negative height, we're not going to bother with the bottom. But the y is the height, and the x-axis is time. And so we have an unknown starting point. That's what we're actually trying to find, and it's going to decrease over time. But this information right here, after 2 hours of burning the candle, has a height of 23.6 centimeters, and after 5 hours, the candle has a height of 29 centimeters. That gives us 2 points. From the purple, we have 2 points. Our x is in terms of time, and our y is in terms of height, so it's going to be an hour, comma, height for each point. So we have 2 hours, comma, 23.6 centimeters, and we have the point 5 hours, comma, 12.9 centimeters. So it says, what is the initial height? We need to find the y-intercept, or more specifically, when the x value is 0. That's what the initial height is. The initial height, I'll write that here. Initial height is y when x is 0, right? You want to know when no time has passed. When 0 time has passed, we want to know what y is. But that's going to be the y-intercept if you put it in slope-intercept form. But either way, we have 2 points, which means we can find the slope. So slope will make this our x sub 1, y sub 1, and this our x sub 2, y sub 2. Slope is going to be m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1, just because we haven't seen it in a while. And that'll be 12.9 minus 23.6 divided by 5 minus 2, which when you plug that into your calculator, you'll get approximately negative 3.57. So approximately negative 3.57 is our slope, and that rate would mean that it's decreasing. The height of the candle is decreasing about 3.57 centimeters per hour. And then you can use whichever point you want, but I've already labeled this my x sub 1, y sub 1. So using the slope point slope form, y minus y sub 1 is equal to m times x minus x sub 1. We'd get y minus 23.6 is equal to negative 3.57 times x minus 2. And then we'll distribute and add the 23.6. You'll get y is equal to negative 3.57x plus 7.14 plus 23.6, which gets you y is equal to negative 3.57x plus 30.74. So we can immediately claim, because we're finding the y-intercept, but you can also, because maybe it didn't ask what the initial height is. Maybe it says what will be the height after 6 hours, in which case you'll plug in that value, x equals 0 in this case, and y will equal negative 3.57 times 0 plus 30.74, which gives us that the initial height is 30.74 centimeters. And so those are some examples of quote unquote real life situations. I know it's who's sitting there actually measuring the height of your candle as time goes on, but whatever. Maybe you're really, really bored one day. The last type of application to lines is what we call the average rate of change. So definition. Let f be a function defined on an interval AB. It could be defined more than AB, but let's just say it is at least defined on that interval. Then the average rate of change, the average rate of change of f on the interval AB is given by the formula. M sub AVG. Some people write M sub secant, M sub SEC. I like to use M sub average is equal to F of B minus F of A, all divided by B minus A. That is the average rate of change formula. Now, I know what you're thinking. Whoa, 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 Phil, that's a new formula. No, it's not. It really isn't. This is just the slope formula with function notation. I'll explain. So visually, we've got a picture here. Like, let's just assume this is some generic, this is just the graph of the function f. And so here's the point A. Let's use, we haven't used green in a hot minute. So this is A, this is B. And so this is an arbitrary graph. The y value of the function at A is the function value. It's f of A. And then similarly, this is the function value at B, so f of B. So this is the point A comma f of A, and this is the point B comma f of B. And we're trying to find the slope of this line. Call that, like, you don't need to write this, but call this x sub 1, y sub 1, and this x sub 2, y sub 2. Then it fits directly into the slope formula. Y sub 2 minus y sub 1 is equal to x sub 2 minus x sub 1. It's just the slope formula, but using function notation. We call this line, by the way, just for some from informational purposes, this is called the secant line. So when we're finding m sub the average rate of change, we're finding the slope of the secant line. And that's all it is. So let's do some examples so that we demystify it, we make it not seem as scary. So find the average rate of change of the following functions. So the first one is the function f of x equals x cubed minus x plus 2 on the interval 1, 3. So since it's on the interval 1 to 3, that means that our a value is 1 and our b value is 3. So m sub avg, by the definition of it, is f of b minus f of a over b minus a. So that would be f of 3, that's our b value, minus f of a, which is 1, all divided by 3 minus 1. And so you can either calculate it as you're going along, or you can calculate it on the side. I'm going to calculate it on the side for this first example, and then I'm going to calculate it while I'm doing it in the second example. So f of 3, that's just going to be plugging in 3 into the function. So that's 3 cubed minus 3 plus 2, which if you plug that into your calculator, you'll get 26. If you feel comfortable either just putting this in your calculator and writing it down, or if you just want to write f of 3 equals 26, that's fine with me. And then f of 1, for a similar argument, is 2, but similar calculation. So this will be 26 minus 2 over 2. That's 24 over 2, which is 12. So the average rate of change, the slope of the secant line of this function between 1 and 3 has a slope of 12. The next one is the function y equals the square root of x plus 2 from a equals 7 to b equals 10. So here they've already labeled the a and b. And so it might seem, wait, I don't have a function. Yes, you do. Yes, you do. This is the same thing as f of x. Y and f of x are usually synonymous, almost always. So m sub avg would be f of b. So that would be f of 10 minus f of a, which is f of 7, all divided by 10 minus 7. So I told you in the first one, I would compute it on the side. Now I'm going to compute it as I'm going along. So f of 10, that would mean plugging 10 into this expression. So that would be square root of 10 plus 2 minus the square root of 7 plus 2, all divided by 10 minus 7, which is 3. That's going to be the square root of 12 minus 3 divided by 3, or approximately, depending on whether they want an approximation of the exact answer, 0.1547. So that is our average rate of change of the second one. Last problem for this unit is example 12, which is you're given the graph of a function g below, and you're going to find the average rate of change from x equals -4 to +2. So first off, that means that this is our a value. A is equal to -4, and b is equal to 2. So that means we're going to be calculating m sub avg is equal to g of b, so g of 2 minus g of a, so g of -4, all divided by 2 minus -4. And you might be thinking, Phil, I don't have a function to plug in those values. I don't know what g is, so I can't plug it in. Yes, you can. If you remember Phil's theorem from last week, remember, and I'm going to use shorthand here, a comma b is on the graph of a function if and only if f of a is equal to b, right? So the b value is your function value. Whatever your y coordinate is, that's your function value. So for x equals -4, g of -4 is 5. So I'll plot that. So here's the point. G of -4 is equal to -5. G of -4 is the function value. It's the y value when x is -4. Similarly, at 2, we have this point, and g of 2 would be 7, because g of 2 would be the y value when x is equal to 2. So we have everything we need. The only things we needed were g of 2 and g of -4, so we have everything. So g of 2 is 7 minus g of -4, that's minus -5. And then 2 minus -4, that's 6. So this would be 12 divided by 6, which is 2. And you'll notice if you go up 2 over 2 over 1, up 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 2 over 1, you see that you've got the slope of the secant line. It's 2. And that will do it for this video, and I'll see you guys on the next one.